All right, here's our current structure where we're using inheritance to support various ways of storing data in the cloud. So at the top of our hierarchy, we have this CloudStream class that stores data in plain text in the cloud. And we have 3 subclasses for storing data as encrypted, compressed, or encrypted and compressed. As you can see, this approach is not very flexible. It's not very maintainable. Because if tomorrow we introduce a new feature like logging, we have to create 4 new classes to support storing the data and logging this operation at the same time. We have to create one class for storing plain text data and logging this operation. We have to create another class for storing encrypted data and logging this operation. So this approach is not very flexible. That is why we have the old saying, favor composition over inheritance. It doesn't mean inheritance is bad. It's definitely a great solution to a lot of problems, but it's not the right solution to this problem. So let's see how we can use composition to support various ways of storing data in the cloud. We should introduce a new interface called stream. And in this interface, we declare the operations that we need to support in various types of streams. So we can create 2 implementations of this interface, such as CloudStream and encrypted CloudStream. So the real name of this class is encrypted CloudStream, but I simplified it to encrypted to keep this presentation clean. Now you might say, but Mosh, how is this different from this original diagram? Well, here we're using inheritance. So these classes are inheriting the code in their base class. So in the write method of, let's say, the encrypted class, first we're going to encrypt the data, and then we're going to call the write method of the base class to store that data in the cloud. In contrast, in this diagram, we are not using inheritance because this stream type is an interface. So in the write method of the encrypted class, we're not going to call the write method of a base class. There is no base class. So how are we going to write the data to the cloud? Well, in this class, we can have a private field of type stream. So we're going to have a composition relationship. And with this, our write method is going to look like this. First, we're going to encrypt the data, store it in a local variable, and then we're going to call the write method of this stream object. In this class, we don't care what that stream is. We simply talk to this stream interface. Whoever creates an instance of the encrypted class will figure out what type of stream to pass here. We can pass a class stream or a compressed stream. The encrypted class doesn't care. And this is what we call the decorator pattern. It's a very useful pattern, and it allows us to add additional behavior to an existing object. In this example, this encrypted class is a decorator because it's decorating this CloudStream object, it's decorating this write operation with some additional behavior, in this case, encryption. Here's the more abstract structure of this pattern that you find in the Gang of 4 book. So we have this component interface. This component declares an operation, and this is the operation that we're going to add additional behavior to it. So we have a basic concrete implementation of this component, and we have a decorator that also implements this operation. In this implementation, we have some additional behavior, and then we call the operation method of this component. So as you can see here, we have a composition relationship. This decorator has a private field of type component, which gets initialized through a constructor. So first, it's going to execute this additional behavior, and then it's going to delegate that operation to this component. Now, in this example, we have this additional behavior before this operation. It doesn't have to be. We can execute this behavior after this operation. So let's see how we can implement this pattern in code.